Hello everyone, today I'm going to show you how to make this grass react to these objects, as you can see here in this demonstration. So as you can see, along this path where this ball moves, you can see this grass is trampled, and also along the path where this character moves around, you can see the grass is trampled. So I'm going to show you how to implement this effect in Unreal Engine. So this would work, this grass reaction system would work regardless of number of characters present, number of objects that reacts with the grass. So it will work for any number of characters and any number of objects. So if I duplicate this like this, still this will work. See, alright, let's see how to implement this effect. And this episode is sponsored by these generous patrons. Thank you very much for your support. Okay, so this is my previous project where I worked on a snow landscape deformation, as you can see here. Now I'm going to use the same system and make it work with grassland, where the grassland will be, the grass meshes will be affected by these same way the snow is bent. Okay, so let's see how to do that. First I'll create a new map with new level like this. Select default, no need to save this. I'll delete these things, I don't need them, and set the light source to movable, skylight also movable, so that I don't have to build lighting for this case. And let's create a simple landscape like this. Let's add some shapes to that. Right, and I have imported this grass mesh to my project, and this material is quite simple. It's just the texture like this. Blend mode is masked, so I connect this alpha channel to this opacity mask, and base color, simply base color, and metallic and specular is 0, roughness is 0.6. Actually I'm not really trying to make a realistic grass shading or anything. I just want to work on how to make the grass mesh affect by the footsteps and other physics objects like the snow deformation. I'll save this map, grassland, and let's go to the foliage. Let's drag and drop this grass mesh here like this. Let's set the density like 800, and radius let's increase like this. Okay, I think this grass is enough. Right, now how to make this grass affected by the footsteps and other objects. So to test that, first I'll Yeah, I have this runtime virtual texture RVT. Now I'll change its name to RVT landscape, because if I use the RVT snow also in this level, it kind of, the name doesn't match, so that's why I changed it. And I have this RVT volume blueprint created before for the in the snow deformation part, so I'm going to use that as well here. If you don't know how to if you're not sure how to do that, just refer to my this landscape deformation in Unreal Engine tutorial, which I did like a couple of days ago. There I showed you how to set up this basically this RVT volume and landscape. So alright, so I'll drag and drop this RVT volume, set the source actor as landscape, and copy bounds. It doesn't really match the bounds, but this is enough, it covers the necessary area. And I have used this RVT lens as the runtime virtual texture. Now let's drag and drop a plane like this. It casts a shadow. We don't need a shadow, so I'll disable cast shadow part. And here under render to virtual textures, I'll give RVT land. So here I'm just going to test some stuff like where this object is right into the RVT landscape, RVT land virtual texture. I want to make this grass bent, like kind of trampled. So for the material of this, we have this, no, let's, these are for footprints, deform source, okay, no, yeah, actually I can use this deform source sphere material here like this. So actually, in order to use runtime virtual textures, if you don't know, you have to enable them in the settings. So I have already enabled it, so I can use them in this project, but if you don't have, you have to enable it. Okay, now this is the source where I just set as 1, where I need write to this virtual texture output. Under base color it writes 1. So this is same as for the landscape snow deformation part. So let's now go to mgrass, and here let's get a virtual texture sample RVT input. Let's name it RVT input, and as the source I'll use RVT land. Now for now, initially all I need to see is some reaction of the grass when there is some object that writes to the runtime virtual texture. So let's get the base color and multiply it. Now let's just get to a component mask, get only the R value, and let's multiply it with the, let's say, a vector parameter. Let's call it bend amount. Let's set it to like 0.5, 0, -1. because so this would be kind of like downward bending, and we can multiply this with a multiplier. Promote to parameter bend density, give it as 10. I'm not sure, it could be too much, and add it to world position offset. Apply. Now do we see any difference under this area? Yeah, I do. See, now we have a reaction. Let's see for the footsteps. I think we have a reaction, but it's very subtle, not enough. And it's not visible anymore. Maybe we need to simulate. Where's the plane now? I can't move it. Okay, in order to move it, we have to make it movable. Okay, we can see the reaction there. But it's just kind of moving downward. That's not exactly what I need. Anyway, let's add a sphere, just like in the previous case. Oh wait, we already created a blueprint for that. Physics object, yeah, these ones. Let's put one of these and see if we can see a clear path. We do. It bends the grass, as you can see here. But I'm not satisfied with the way it looks. Okay, so let's instead of directly pushing the grass downwards, let's modify this material a little bit. Let's say, shall we create a new texture? Yeah, let's create a new texture to define the way the grass should deform, the grass should bend, in order to have the trampled look on that. So we can actually use, so here in this deformation input, instead of 1 we can use a color like RGB values to define the direction. But before that, let's modify this a little bit. So instead of using this scar, okay, in Photoshop, let's create a new 256 by 256 texture, and I'll divide it to 4 sections basically. So the reason to divide it to 4 sections is I'm gonna have different color values like this. So here along this axis I need let's have a brush and a new layer. this x-axis I'm going to use as the R red axis, and this one as G. So here R is 0, here R is 1. R0, R1. Here G0, G1. So I need to have a gradient that varies according to this. So here it would be 0.5 by 0.5. Actually R1 means 255 according to color wise. 0.5 means 127 roughly. Okay, so let's add a new new layer and select the gradient tool, this one. I'll select R as 0 and G as 0. That means this corner, and this corner must be R is 0.5 and G is 0.5. Oh, 0.5 means 127. Okay. Oh, wait. What about this point? This point is 0, 1. Okay, let's let's delete the whole area and select only this square, and in the G draw like this. Okay, now this square here 0.5, 0.5, and here 0, 1 should be the color. So I select this part again, go to gradient. This is 0.5 by 0.5 already, so I'm not gonna change it. Here it should be R 0, G is 1. Why didn't I change the value? Sorry, G is 255. How is it 256? I think 255. Anyway, not much of a difference. Well, we don't have a perfect gradient here, but I think that would not be much of a problem for our purpose. So this part should be here 255, 255. Okay, and here 2550. Okay, now let's save this under RVT. cross reaction. Let's save it as a PNG and import it to our project. Okay, now I am going to use no deform source sphere. Okay, let's create a new material. Let's duplicate this. It's no deform source. No, let's call it grass deform source. And deform source grass. So instead of using 1 as the base color, I'll use this texture. And for this plane, let's use this deform source grass as the input. So still you don't see much of a difference, but let's modify the grass material now. So I'll delete this and no, let's keep only the bend intensity. So now what I want to do is I want to bend this grass based on the color input I get here. So actually I get R, G and B, but here only R and G values matter because B is vertical axis, usually represents the vertical axis, and along the vertical axis, when in the root of the grass, it should not have any deformation, because if I add any deformation along the vertical axis here, it would simply move down the landscape, which makes it invisible. So let's break this to float 3 components, and then let's again use a make float 3. So I'll use only R and G values from this, and I'll get the B value from texture coordinate. Here we can do a mask, component mask, and get only the G value. When the G is 0, it wouldn't have any vertical bending. In the bottom of the texture, G is 0. Or is it top? I don't remember. Okay, let's check. Let's see how it looks now. Okay, let's simply connect this and multiply with the bend intensity. Let's try sort of 10, maybe 20, and put it as the world position offset. So here I think you remember we had a problem when we don't use a base color for emissiveness or base emissive color or base color. It doesn't give accurate results for some reason. We experienced that before, but let's see how this looks. Grass. Oh, it's all trampled. Everywhere it's trampled. Right. Okay, so now we have the trampled look. So let's do something like this. Let's get the base color and subtract 0.5. This way I think we should be able to bend this with both sides, because we can get values from minus 0.5 to plus 0.5. And let's have if condition, then as the input, oh sorry, I should use this one as the input for this. And so we can get the vector length of this base color. So if this has some value larger than 0, that means we have a value in the RVT virtual texture which has some input, which it says that we have some input there. So if a is larger than 0, I'm gonna give this one as the result. Otherwise, let's make a constant of 0 and return it. And let's use this as the input for this multiplication, and let's see how it looks now. Right, now you can see only where this plane is present, the grass is trampled. But you can see it's not actually, this change is not smooth. So we can fix it like this. I don't know why it works, but we know that from the previous experience. If I multiply this with 0, actually this is a useless operation, but it invokes something and makes it work. See, now it becomes very smooth. We have the trampled look in the grass. Okay, now let's select this sphere, this object, and as instead of this physics object, let's open the blueprint. Here it spawns this BP footprint child. So this is actually snow. Let me open it. Here we use this snow texture, this material that affects the snow. So I want to change this. So let's go here, create another child of this PP footprint grass, and here instead of this deform source sphere, I'll use deform source grass. Okay, save. Now let's see. Now you can see this grass is affected by, trampled by this object, like that. And it resets over time, which doesn't look very good. So maybe we should be able to override that. Let's check the parent character. Timeline 1. Let's give this a name. This is the destruction part. Yeah, it's okay. So what about the footprints of the character? If I play it, you see it's not very accurate. So what can we do about that? We can open the character to make it properly work with the grass. Let's modify this a little bit. We spawn BP footprint, which is this object. Let's see how it looks. Like that. Okay, so it has to be smaller. Well, let's make this much slower, destroy one. For now, let's get rid of this destroy part. Oh, it seems unnecessary at the moment. Okay, so how to make, let's work on the footprint. So instead of making it this size, let's make it much smaller to make it work with the grass. So what's the optimum size? Let's say 0.5, 0.4. Let's try this scale and see how it looks. Actually, that looks better. And also the 2 foots. We have these planes. They need to be smaller too. Be something like this. Right, let's see. Yeah, that's better. Okay, so I think we can stop this episode right here. Okay, so as always, this episode, the project files will be available for the download here in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. Thanks for watching. See you in another episode. Goodbye.